Hi, everyone. We are the HPC group of the Data Science Clinic. My name is Vane, and I'm a fourth-year data science major.
My name is Keling. I'm a second-year MS CAP student.
And I'm Jimmy, also a second year MS CAP student.
And my name is Hieu. I'm also a second year MS CAP student.
As some overview to our project, we had the pleasure of working with Bennett Hunter and Nick Ross as our external and internal mentors, and our TA was Justin Wang. As some context, the DSI operates a high-performance computing cluster that caters to many users, and grasping the current and future states of its usage can help allocate resources of the cluster more efficiently. Some of the goals of our project were to visualize and predict HPC cluster resource usage over different timescales using time series analysis, and to also create dashboard pages reflecting cluster metrics that are interactive. This project matters in order to improve the resource allocation and the performance monitoring for the cluster, which is critical to support the computational needs of those who use it, and to also extend the features for the DSI cluster status page. As for the data that we used data dumps collected from DSI's Grafana account, which is managed by Bennett, and we use 8 kinds of CSV files that include CPU, GPU usage, the status of submitted jobs, and the memory usage of cluster nodes, and the time range of this data is from November of 2024 to March of 2025.
Okay, and after we have a look at our data source, the next question we would like to ask is what aspect of the data we would like to focus on. So here we focus on 2 kinds of time series data collected from the cluster. The first is the CPU and GPU utilization rates, and the second is the logs of the cluster job data. So for these two kinds of data, we send them into pipeline for data cleansing and feature preparation. And then we send them into the production environment to visualize the dashboard and model evaluation report. And the reason why we choose these 2 kinds of data sets is first, for the cluster used for research requires consistent uptimes, we want some precautionary workload alerts. And the second is for tracking the details, for example, like the work duration and the waiting time of the job submitted by different users. For these kind of metrics or informations, we can help improve user experience. Next page, please. Okay, so for here, we have our dashboard prototype to unravel the patterns for advanced analytics and model predictions. So the benefits of the dashboard is, for example, like the users, like researchers would benefit from being informed about the numbers of pending jobs or the job status and the current estimated waiting time in order to adjust their research progress. Next page, please. And the next step for our project is the for data exploration. So the first question we'd like to ask is, what is the pattern of the resource utilization since the November 2024 in our data sets? So on the right-hand side, we can observe that the GPU utilizations over time is like bearing a heavy load compared to the CPU. So here for the model prediction, we choose to focus on GPU utilization rates rather than the CPU ones. Next page, please.
So this slide shows the distribution of CPU and GPU utilization. And on the left, the CPU utilization distribution shows a peak around 40%. And this indicates that most CPU tasks are operating at moderate capacity, while on the right, GPU utilization is skewed heavily toward higher values. The majority of usage clusters between 70% and 100%. And this shows that the GPU resources are being utilized much more intensively. And this also points to our goal to predict future GPU usage and give warnings beforehand. Next, please. And now we're seeing the ACF plot. This chart shows the correlation between the current hours usage and the usage from X hours ago. So for example, the correlation between the current GPU usage and that from 24 hours ago is about 0.7. We can also observe a noticeable pattern. The correlation dips more deeply every 24 hours, and this suggests a daily seasonal trend in GPU usage. So to capture the most predictive patterns between now and the past while preserving the daily seasonality of GPU usage. We set the prediction window to be 24 hours. This means we use GPU usage data from 1 to 24 hours ago to predict usage in the future. Okay, next please. Okay, so summarize the previous slides. Our goal is to predict whether GPU utilization in the next hour will become intense. So we define extreme utilization as exceeding the 84th percentile of historical GPU usage. So to classify future usage of GPU, we evaluate model performance using the F1 score, which balances precision and recall, and which is particularly important in our case given the imbalance in extreme events. Okay, so to build our models, we use several types of features. So first, lag features that capture temporal trends in GPU and CPU utilization across the past 24 hours. And second, some time-derived features. And third, we use some external cluster features such as memory usage and load average. So we tested 5 models that are commonly used for classification tasks, which are KNN, SVM, ADA Boost, XGBoost, and logistic regression. Next, please. So the next slide, we compare the F1 score of the models across the 5 models in a training, validation, and test framework. So we can say XGBoost performs the best in testing and also in validation dataset, while KNN shows some signs of overfitting. And we also use tools to understand what features contain the most information. Next, please.
So this is an example on the model that we did. This is support vector machines, and we use it to try to predict the high level of usage of GPU in the next hour. As you can see that on both the training and the validation set, the model is doing pretty well. The red dots mean we should pay more attention to the predicted high usage. And we can see that the most of the red dots are above the third quantile threshold, which is at 85% of usage. And here is the individual contribution of the features to the predictions. As you can see, 1 hour ago has a huge positive weight, which indicates a strong predictor for the higher utilizations. This makes sense because, like, what 1 hour ago is the most recent features in the data. 3 hours ago and 32 hours ago have some strong negative weights, meaning there's a cooldown in the next hour from the past. Thursday and Friday are the 2 weekdays that have high weights. This indicates that most of the usage could focus around the end of the work week. And in the future, we also want to consider more nonlinear and interaction features to enrich the predictions. Some of the results. Overall, we create interactive, insightful dashboard that can be integrated into the current status page for the DSI cluster. We also successfully designed the pipelines that we hope to be used as backbone for future improvements. And we try to demonstrate that with some reasonable feature engineering. For example, that and weekdays, we can have predictions from conventional models that are also very effective. Uh, Challenges. In general, we would want to collect more historical data to improve the model, and we also want to refine the evaluation with well-defined metrics and more specific objectives. And since this is a time series data, we would want to have more complex features other than some simple lab features. So, and we also want to consider implementing time-sensitive models like RNN, LSTM, or transformers. Lastly, we also want to enrich the signal by adding more transform features such as like calendar-based events, research conferences or maintenance periods. And we also want to add like user or job level metadata with some other cluster data as well. Thank you for listening.